Welcome everybody to How to Write Pytest Plugins. Thank you for your enthusiasm for Pytest and hopefully the testing that comes along with that. A little bit about myself. I was born and raised in Silicon Valley. I've lived there my entire life. It never seemed to be the most exciting place, but one day HBO created a television show about it, and I thought, who would want to watch a TV show about Silicon Valley? And then I finally watched it, and it was really hilarious, especially because everything that goes on in that show is completely true. So along the way, I've worked at a number of different companies in Silicon Valley, doing various things such as developer tools at Cisco, data tools at Nearby Now, security tools at Juniper, build tools at Tango, which has led me to my current role in tools and automation at Palo Alto Networks. So why do you want to use Pytest? Why do you want to write Pytest plugins? You all already have used Pytest and you're all excited about it, and it has so many great features that have been a step up from using unit test. Well, by writing and using plugins allows you to customize the behavior of Pytest. For example, by using the Pytest ordering plugin, you can customize the way that your tests are, the order that your tests are executed in. There's another plugin available called Pytest Sugar that allows you to get a progress bar to show you how far along your tests are running. And today I'll talk a little bit about a custom plugin that I've written to give you a different kind of a report. Another reason you might want to use Pytest plugins is to just extend and integrate your framework, such as using the Pytest coverage plugin to take a look at the coverage of the test coverage of your code. And a really fun one is the Pytest Slack, so that you can get a Slack notification when your tests have completed, and it'll send you an emoji, and everybody loves emoji, so that's a lot of fun. And today I'll also share with you about a plugin that I've created to upload your test reports to Google Cloud Storage. So this is kind of what I think of as the evolution of a Pytest plugin. I found it easiest to start off with writing fixtures and hooks, which are the building blocks of your plugins. And from there, you can go into writing installable plugins so that you can pip install them in other repositories that you're using. And then finally, if you want to distribute your plugins for other people and other people around the world to use, you can create a distributed plugin, which I won't go into detail today, but it's basically like packaging and publishing any other Python package on PyPI. So let's start our evolutionary process with the fixtures. How many of you have written fixtures in Pytest? Okay, cool. So you're all familiar with it. It's basically your setup and teardown, getting ready for your tests and cleaning up afterwards, in a nutshell. Some examples for those of you who haven't used fixtures: it's commonly used to retrieve data to prepare for your tests. I like to use them for loading and parsing configuration files that will be used throughout your tests. Another example would be for getting data from the database that you need for all your tests, or for creating, setting up and tearing down different resources that you would use throughout your tests. So here's one example for those of you who haven't seen it before. In this example, we'll create a database connection that will be used throughout the rest of your tests. So you'll just create a MySQL connection, and then when you yield the connection, then all your tests would execute. And at the end, you would close the connection. Pretty straightforward. But then why would you use a fixture instead of just a context manager? Well, these fixtures are reusable, and the really cool thing is that you can set the scope for your fixtures. So in this example, I've set the scope to a module. So this connection will live for the duration of your test module. Which is really handy, and you could scope fixtures for a function, for a class, for a module, or for your entire test session. So you would only create, in that case, you would only create the database connection one time, and that's a lot more efficient than creating it for every single test function, depending on your use case. And so by putting your fixtures into your top-level conf test file in Pytest, you have basically already created a local plugin. So those of you who have used fixtures already, you're already familiar with how to create a local plugin. So next, there are hook functions. And these are basically places in your Pytest code that you can implement these functions to change the way that Pytest works. And by creating a hook function in your top-level conf test file, once again, you've created a local plugin. I've listed a few examples here that we're going to talk about today, but there are many more listed that you can find in the reference documentation online. There will be a URL at the end, so don't worry. So the first time I thought about hook functions, I was really confused about what they were and how you use them. So this graphic on the right-hand side is just kind of a mental model that I've selected in my mind. If it doesn't work for you, then don't worry about it. But I like to think of it as this is the Pytest execution from top to bottom. And along the way, there are these different functions that you can implement. And if you don't implement them, it will just go ahead with the default behavior. But if you do implement these functions, Pytest add option, Pytest configure, Pytest collection modify items, and Pytest session finish, by implementing those functions, you can change the behavior at those points in the test execution. With, very importantly, also the actual test execution going on in between. But this map is not drawn to scale, so don't worry about the details too much. So how did I start writing a plugin in the first place? Well, with all projects, it starts with the manager coming to me and saying, Darlene, you know, you and the rest of the testing team have written such great tests, but the upper management has no insight into it. And I said, well, they can look in the repository, right? But he said, no, can you make us a CSV report that just lists all the test case names? So, okay, I can do that. That's easy. I don't need to write you a script for this. And he says, well, Darlene, they also want information about the markers that are used for the tests, and they want the docstring information. I said, oh, okay, well, my hacky way of doing this is not going to work so well. I thought, oh, wait a minute. There is something that exists that already knows how to get to all the test cases, knows about the test markers, and knows about all the doc strings. And that's Pytest. So I'd remembered reading about Pytest plugins, and so I went to research that in a little more detail. And then I decided, okay, I'll write a Pytest plugin. We're going to call this Pytest test plan. And this plugin will allow us to generate a CSV with all the test names, the descriptions, and the markers, and then exit. So back to this mental model that I described earlier, we'll implement Pytest add option hook function. We're not going to do anything with the Pytest configure. We're going to implement Pytest collection modify items. And then we're going to exit. We're not going to run the tests to generate the CSV report. We just need to know the information about the tests, but not actually run them at the time that we need to generate this report. So those are basically the steps that went into creating this plugin. So starting with the first step, creating the command line options. It's basically the same as using argparse. I created the command line option where you would specify the name of the CSV file that you would want to create. And then when you run pytest --help, this is the custom option that would show up along with all the rest of the built-in Pytest options. So from there, the Pytest collection modify items is a little more interesting. So I wanted to make it optional, so only if the user specified the test plan command on the command line, then you would go through these steps of creating the CSV. So then you would create the CSV writer, and then this items object that Pytest gives you already contains all the test information, because this is this hook function will execute after all the test collection has already occurred. And so from there you can get the test title, the description, in which I strip out some of the white space because the doc string has all the indentation in it. So when I generate the CSV report, I didn't want all the indentation included in that. And then I created a string with all the marker names separated by a comma. And then finally, I write this out to the CSV file and then just exit. So I'll show you what that looks like. First of all, this is just some silly test code that I wrote just to see how this would work to generate the CSV report. So these are just some generic test functions just to show a mixture of having test functions, different markers, and test methods in a class. But don't worry about what the tests actually do, because they don't do anything but assert true and false. So I run this from the command line and specify that I want the test to be written out to testplan.csv. And as you see, this this message says that none of the tests ran, which is what we wanted. We wanted just to generate the report, not run any tests. And then I've displayed the CSV for you at the bottom. And then there you go. You can give the spreadsheet to the upper management, and they'll know what are the tests that the team has written, some the doc strings from the test, so that they know a little bit about a little more about what the tests are, and then some of the markers. So finally, the upper management is happy. They have all the information they want. Then my manager comes back. Says, well, the upper management is happy, but the developers, they cannot see the HTML reports because you've created. So we've been using the Pytest HTML plugin to generate the final reports in HTML format. But they're all either on the Jenkins server or on our laptops, and the developers don't know which tests are passing and which ones are failing, or they don't have any insight into it. So I thought, oh, maybe I can just add to the Jenkins job a script to, just run the tests as normal and then send the report out. But after some discussion with my manager, we decided that ultimately we want the test reports to be stored on Google Cloud Storage. So, because if we email these reports to anybody, who's going to click on the email and actually look at that report? Are you really going to click on it and look at it? No. So I'll put them on Google Cloud Storage, and anyone can come and look for the test reports anytime they want. So that led me to my next plugin, which we want to just generate the HTML test report and then upload it to Google Cloud. So as I mentioned earlier, we're using the Pytest HTML plugin already, so that's the first step in this process. And then I want to implement the Pytest add option hook function to, again, specify some things on the command line, which you'll see in a second. And then implement Pytest configure to manipulate the configuration a little bit. And then at the very end, after all the tests have executed, at this point, that's when we want to upload the test report to Google Cloud. So I don't know if you can read this in the back, but it's just creating all the command line options. The first option is to supply the service key for the Google Cloud credentials so that you can that you'll be authenticated to your account. The next option is the GCS bucket name, so that you know which bucket you want to store your reports in. And this would be similar, like if you were using AWS, you would use your AWS bucket or any other cloud storage where you would want to upload your reports to. And then finally, I've created an option for you to specify the file name for your report. So this is the hook function, Pytest configure, where we've checked for the existence of the command line options. And here I've decided that if someone specifies, like, say, the bucket name but doesn't specify the service key, we don't want to proceed unless they've specified all. They've either specified none of the options and we don't do this, or they specify all the options and we'll proceed with this upload. So then we'll get the HTML file, the HTML file name, and I decided I wanted to prefix everything with the timestamp, which is why I have this timestamp included everywhere. And the final line is an option that is part of the Pytest HTML plugin, where if you set this Boolean, then it will include the CSS in the HTML report. And I wanted to set that to true so that it's easier to view on the Google Storage bucket. Like when you browse in the bucket, you can click on the file and it will have all the CSS included in the HTML for you. So that was just manipulating all the command line options. And now this is the actual upload to GCS. So at this point, we take the HTML file name, and I've taken our timestamp from our test run and created some subfolders, including the year, the month, and the date. So that way, if you ran the test multiple times in the date, you could just go to that one folder. It just came out to be better organized in the Google Storage bucket because it's not that, it doesn't give you too many options to sort or search through your, it's basically the sorting that is not available, so you can't sort them by date. And I found that with test reports, they're easiest. You usually want to see the most recent one. You don't care as much about the test reports that happened 2 weeks ago. And then finally, we do the upload to Google Cloud Storage using, this is a separate wrapper library that I had created. So we can take a look at this. These are the command line options that we've built. And this is how we specify passing the credentials, the bucket name, and the sample file name. And you can see this is, we could see that the test report is uploaded to the cloud. This is what it looks like in the cloud. So I'm sorry, it's a bit small, but there's subfolders with the year, the month, the date, and like these headers with the name and the last modified. Those I thought you would be able to sort on, but you can't, which is why I've separated everything into these files, into this folder structure. And if you click on one of the reports, this is what it looks like. And again, because I included all the CSS into it, that's how you get all the colors and the filters directly from GCS. So those two examples that I talked to you about are local plugins. Those are examples of local plugins. And I mentioned that you would implement all of this in your conv test file at the top level of your repository. But over time, if you do a lot of different plugins, it will be hard to organize within one file. So I wanted to show you an example of how you can separate the functionality into an installable plugin that you can just do pip install. So for the first example that I talked to you about, you would create a Pytest test plan repository and copy the relevant sections of your global conf test into a new file, Pytest test plan, and then create the setup.py. Here's the example of the setup.py. A lot of it is just boilerplate stuff, but you would include the name of your test module, the name of your module, and the entry point here. And that's it. With that, you can just pip install this, and you can use this in multiple repositories if you have other repositories for other test cases, or if you're in a large enterprise, there could be other teams with different repositories that could make use of your plugin. And it's pretty similar for the second example with the Google Cloud Storage, with the slight difference that I also want to include. This GCP module, which I mentioned earlier, is just a wrapper that I created for Google Cloud Storage. And so to include that, you also have to specify that you want to include this package. And this plugin also requires the other plugin, Pytest HTML, and also the Google Cloud Storage Python library. But again, it's just as simple to pip install this plugin. So today I've shown you some examples of different plugins, and hopefully you've learned that the plugins can be a lot more elegant than an alternate solution. In particular, with the first example that I showed you, yes, there are other ways that you could accomplish this, but it would have been a lot more complicated to write your own parser to look for all your test case names, extract all your test case markers, extract all the doc strings, and get and you saw how simple it was to just use what Pytest has already given you, and boiling that down into just a few lines of code, and that was a very simple plugin. And I've shown you basically the entire process of creating a plugin. Now, these particular plugins might not be so useful for you and your organization, but by knowing the process, you now know how to build your own. So if you have some idea and you think, okay, maybe there's a way to do this using the tools that Pytest has already given you. Finally, in the last example, I showed you how different plugins interact with each other. For example, in the Google Cloud Storage plugin, that interacted with the Pytest HTML plugin. So that is how you can use plugins to build on top of each other. And I promised you a link earlier, so this last link, the first one that says available hooks, that is a very handy reference for all the different hook functions that are available to you. And there was another tip I have for you, which is there isn't a ton of documentation there. This is basically the source code. So what really helped for me is just to implement the hook functions with nothing but setting a breakpoint in there to see what was available. For example, if I go back, let's see. Okay, where was it? Not this one. Oh, okay. So in this example, how did I find that this iter markers function or the node ID? Well, basically, I just created this Pytest collection modify items function with nothing but a breakpoint in there, and then I could look at what attributes this items object had, and that was the process of finding out what you could do with the list of items. same thing with the config and the session as well. So okay, let's get back to the references. And the book Python Testing with Pytest also has a lot of good information about, well, Pytest in general, but especially the fixtures, the hook functions, and writing plugins. But I think that the examples that I presented to you today are a little bit more real-world examples, because when I first read those examples, I was still confused as to what are the real-world use cases that you would need plugins for. And then here's a link to the Pytest HTML plugin, which I've talked about a lot. Thank you very much for coming. And if this topic is interesting to you, Palo Alto Networks is hiring, and we don't just work on plugins. We also write the test cases and do other automation tasks as well. So you're welcome to come and talk to me about it if you're interested in that. And we're also working with a lot of big data tools. So that's it. Thank you.
If anyone has questions, let's go with it. How about you first?
So great talk. Thank you for this.
Thank you.
I know this is
Thanks
probably another topic in itself, but how do you test your Pytest plugins?
Oh, that is another topic in itself. Yeah, the example I showed you was just more for the purpose of this talk. There is an example in Brian Auken's book. There is a section in there on writing the tests for the plugins, but I don't have an example to show you. Yeah, but there is definitely a section on that topic in this book. Oh, sorry. The question was, how do you test the plugins?
Hi, Darlene.
Hi.
My name's Paul.
Hi, Paul.
In terms of the HTML report, is it easy to override the CSS styles?
Yeah, so the question is, for the Pytest HTML plugin, is it easy to override the CSS styles? Yes, I believe it is easy. I didn't actually do it. I had a teammate that worked on that. So it didn't. I honestly don't know, because somebody else did that work.
So you wrote the Pytest plugin, right? Will that be 2 and 3 compatible, or you would have to make a Pytest plugin which is compatible with both 2 and 3?
Oh, so the plugins that I wrote are probably only 3.6 and above compatible, but that. So it would depend on the plugin, and you could write different versions. You could write different versions, and then it would depend on what version your Pytest is using. Did I repeat the question or not? I might have forgotten. Yeah. So the question was whether you have to write the plugins using Python 2 or Python 3.
Any other questions?
How do you generally structure your fixtures? Like if you have a conv test file and it grows like insanely large because you have so many fixtures, at what point do you split that out and how do you do it?
Okay, so the question is, how do you organize your fixtures in your global conv test file?
It's like you personally, I guess.
Yeah, so I personally have, so a lot of my fixtures are specific to certain areas, so at that point I move the fixtures into a subdirectory that is just for a subdirectory of tests. But yeah, probably at some point you could do some. I honestly don't know, because I haven't done that. It hasn't grown to that point, or I haven't organized it to that point yet. some of it would be, as I showed with some of the standalone plugin, the plugins that could be converted to standalone plugin in a separate repository. So moving it out that way. But in terms of other fixtures, I don't have a good answer for you. Sorry. Okay, and we can talk outside if anybody has more questions.
It's actually pretty easy. You can store features in separate folders. The folder just provide the link to the folders in Python context.
And then you have to like import.
So just
star.
import them.
Not import.
No.
There's a Pytest plugins, and you provide the list of these files.
There's a plugin for that. Okay. That's pretty
Okay. So there's a plugin for organizing your fixtures. That's what you're saying. Okay. Awesome. Thanks for sharing that. Thank you.